Okay, so for the two questions for today, differential equations and area and volume, I really like the 2016 questions that they put on the BC exam because I felt like they covered a whole variety of topics, not just differential equations by separation of variables or area and volume by revolving something around an axis. Those things I still think you should go over and be familiar with, especially this, the cylinder method that we had talked about, arc length, maybe have those formulas on hand. But I think what they're going to be asking you to do if you get any questions like this is to do applications, and I think they're really going to tie a bunch of different topics together, and that's why I particularly like these 2016 questions. So for 2016, the first one, 2016 BC4, it says consider differential equation and find the second derivative. Okay, and again, I feel like this is good because this shows your understanding of implicit differentiation and things like that. So what's important is that when you do the second derivative, so you know what, let me write the first derivative down. dy dx equals x squared minus 1/2 y. Because of the fact that that right-hand side is not all in terms of x and you're taking derivatives with respect to x, you have to use implicit differentiation when you do this problem. So the derivative of x squared would be 2x, but you follow that up with dx because of the fact that you're taking the derivative with respect to x, minus 1/2, and this is the really important part, dy dx. So while the dx goes away, the dy dx, you need to take this expression and put it in place of dy dx inside of that problem. Okay, so you should end up getting something like 2x minus 1/2, and then you bring this whole thing down, x squared minus 1/2 y. Now, you could simplify that further if you want to. There's nowhere that it says that you need to simplify any further, and eventually when you use it, you can keep it in that unsimplified form. So I would probably just leave it just like this. I don't see there's any reason for you to try to simplify any further and then somehow risk making some sort of a mistake. Okay, unsimplified is better. Okay, for part B, you're going to be using both the derivative and the second derivative. So it says let y equals f of x be a particular solution. Notice that they're not actually asking you to solve for one. If they were going to ask you to solve for one, this is one of those ones where you would do the integrating factor, although I can't really see something like that necessarily coming up, okay? Like that would come up more in like a multiple choice question on the AP exam, not so much a part 2, but again, maybe these are things that you want to refresh your mind about to make sure that you're familiar with them just in case. So it's asking you to use your understanding of derivative and second derivative to determine if there's a relative min, a relative max, or neither at the point -2,8, which they're saying is on the original function y equals f of x. Well, in order for there to be a relative min or a relative max, you're going to have to take a look at the fact that there's going to have to be a slope that equals 0, okay? If the slope does not equal 0, there's definitely no turning point. And then beyond the slope being 0, dy dx being 0, you'll have to look at the second derivative and see if it's concave up or concave down. So let's start with dy dx. Okay, remember it's x squared minus 1/2 y. So I'm going to plug into that. My x is -2 squared minus 1/2 times my y. So that comes out to be 4 minus 4, which does come out to be 0. So that's telling you, yes, it's definitely not going to be the option that is neither. You're going to have to go further and calculate the value of the second derivative. So in our second derivative, okay, and again, you have a calculator available if you're uncomfortable with doing these calculations by hand. So you're plugging in -2 for x. Okay, watch that squared. And 8 for y. When you work that whole thing out, you should get -4, but more importantly, the fact that that comes out to be negative, that means you're dealing with something that has a turning point but is concave down, so therefore, this is a relative max. Okay, so you would say something like, since dy dx equals 0, and d squared y dx squared is less than 0, there is a relative max at -2,8. Okay, just so you're aware, if it turned out dy dx was not equal to 0, there's no point in even calculating the value of the second derivative. You would just have to say, okay, if the dy dx was not 0, there can't be a turning point, and that would be the situation where it would be neither. Okay, part C. Let y equals g of x be a particular solution to the given differential equation with g of -1 equals 2. Find the limit as x goes to -1 of this expression. Show the work that leads to your answer. I would imagine if you see a limit in a part 2 question, hopefully L'Hopital should be ringing in your head because that's very likely what you're going to have to end up doing. So if I take the limit as x goes to -1, remember your first method of doing a limit is to plug in. Okay, so I take the information that they provide me, and it turns out I have 2 minus 2 over 3 times 0 squared, which is 0 over 0. Okay, that doesn't mean that it's undefined. It means you have to do more, which in most of these cases now means do L'Hopital's rule. So you take the derivative of the top, take the derivative of the bottom, reevaluate the expression. So the derivative of g of x minus 2 would just be g prime of x. The derivative of 3x plus 1 squared, you'll have to do the chain rule. 2 drops down in front. X plus 1 stays the same. We raise that to the first power. Don't forget there might be a derivative of the inside of x plus 1, which in this case there isn't. So you can go further and do your calculation. So you'd end up getting g prime of -1, which comes out to be, did they give you a g prime? Oh, I got it. Because you'll have to evaluate -1, 2 inside the dy dx. So remember, dy dx was equal to x squared minus 1/2 y. Okay, so when you evaluate that, your x squared would be -1 squared minus 1/2 times 2, which would come out to be 0. So this would be 0 on the bottom. I would have 6 times 0, which again would be 0. So once again, I have to do more. Okay, last but not least, means I have to take the derivative of the top and bottom again. G double prime of x, okay? And then that bottom would come out to be a derivative of just 6. G double prime of x means you're plugging into the second derivative with the point that they gave you. Sorry, I should have copied that down a little further. So that was 2 times my x minus 1/2 times the previous derivative, okay, which was 0. And so that comes out to be a value of what, -2? So I get -2 over 6, or -1/3. In fact, don't even bother with the -1/3. Leave it as -2 over 6. As I mentioned before, unsimplified is better, okay, because they fully accept it, and then you don't have to worry about making any mistakes. This last question is asking us to use Euler's method, Euler's method, whichever way you want to put it, with 2 steps of equal size. So that means that delta x in this case is going to be going from 1 minus 0 divided by 2, which will be 0.5. If you remember when we did Euler's method, you want to make that table. So x, y, m, which is really dy dx. So we're going to have to again use the fact that dy dx was equal to x squared minus 1/2 y. Okay, and then we're going to have delta y, which is equal to m times delta x. And then you're going to have y nu, which is equal to y plus dy. Okay, or delta y, I should say. Okay, so you're starting at the point 0, 2. You're ending when you get to the point 1, something. So this is the point where you want to stop, because that will be your approximation for h of 1. Sometimes people go on further, and you definitely don't want to go on further. Okay, so let's start with our dy dx. You're going to calculate the value of dy dx at the point 0, 2. So that would be something like 0 squared minus 1/2 times 2, and that should come out to be a value of -1. Okay, so your m is equal to -1. Delta y is equal to m times delta x, so -1 times 0.5. So therefore your y nu, so this would be -0.5. So your y nu is going to come from y, which is the y in this particular row, minus 0.5 or plus -0.5, and that comes out to be 1.5. Okay, so that goes into my next column where my new y value is 1.5. I had gone up using a step size of 0.5, and now I go back and I calculate the slope yet again. Okay, so you're going to plug in. You're going to do 0.5 squared minus 1/2 times 1.5, and you should end up getting a slope of -1/2. Okay, so I'm going to have -1/2 times 0.5, which comes out to be -1/4. Okay, I'm going to take my y in this part, so that 1.5 minus 1/4 or minus 0.25, and you end up getting 1.25 or 5/4 if you want to leave it as a fraction. I don't think you have to leave it as a fraction. So your approximation for h of 1 is approximately 1.25. Okay, and again, remember, unsimplified is fine. So you could have even have left it as something like this if you really had wanted to. Okay, the other question I thought would be good to go over, because this wasn't a, fully traditional area volume question, I think you should still go back over just so you're familiar with it. Obviously volume of revolution, volume by cylindrical method, arc length, because I think any of those things could come up. I mean, historically in the last couple of years, they've used the polar parametric to test a lot of those things. But that being said, who knows how they're going to do it this year. Again, I liked this particular area volume question because the fact that it ties, again, a bunch of different things together, and I think that is what you should expect to see. In this particular question, I would suggest that you think of this problem like this, because I think that will help you to understand the area volume aspect of this one a little bit better. So it says the inside of a funnel of a height 10 inches has circular cross sections as shown in the figure above. So basically it's created of discs. At a height h, the radius of the funnel is given by this function r equals 1/20, 3 plus h squared from 0 to 10. And everything's given in inches. So it's important that you make sure you write units if units are provided to you in a question. So the first part says find the average value of the radius of the funnel. Average value, that's the formula 1/b minus a, integral from a to b, f of x dx. They're asking you to find the average value of the radius where this function represents the radius. So 1/, what are the heights you're working with in this problem? 10 minus 0, because that's the interval that you're working on for heights. Integral from 0 to 10, and then your function will be 1/20, 3 plus h squared dh, right? So as you go on further, you would use your your integration rules to be able to integrate this, okay? And again, I'm not going to spend too much time on the integration part of this. I wanted to focus a little more on the setup, but eventually you should get something like 1/200, evaluating 3 plus h cubed over 3 from 0 to 10, and eventually you would see that that comes out to be 109/60 inches. Again, because you're talking about a unit for a radius, not an area or a volume. And again, remember, use those units, don't forget them, and also leave unsimplified answers. For part B, find the volume of the funnel, okay? And that's why I had said, think of the function or think of the funnel in this way. So you can see, okay, that's basically revolving something around an axis, right? So each individual cross section comes from the area of a circle. So pi times the radius squared, integrated from the beginning of the funnel to the end of the funnel, which is 0 to 10, right? And then this time my function r is in terms of h, so it will be dh. So if I take the information that I have in this problem, the fact that this right here, this radius, is that function 1/20, 3 plus h squared. Okay, so integral from 0 to 10, I'm going to put that pi out front. I'm going to have that radius 1/20 times 3 plus h squared, that whole thing has to be squared dh. Now again, I can't imagine they're going to give you a ton where you have to evaluate these things out by hand, nor I think this is going to be more one of those set up but do not solve type tests, because of the fact that not everybody's going to have a calculator. But if you were to actually integrate this whole thing, and again, you can see all these solutions available online, you'd get something like pi/400 multiplied by the integral from 0 to 10 of 9 plus 6h plus h squared, oh goodness, let me just rewind this, okay? You know what I'm going to just say? The final answer for this one comes out to be 2209 pi/40 inches cubed. In the effort of saving time, just go look up 2016 question 5, and you'll see all the steps of this integral worked out if you want to see the actual integral. Again, once more, leave unsimplified answers, and don't forget units if they give you units in these problems. All right, again, another thing I liked about this question, They threw back to something from AB that you really don't see a lot when you're in BC, but remember, AB and BC all blend together at this point. This is a related rates question, so I think it's important that we go back over this. It says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So remember that your radius function was 1/20 times 3 plus h squared, right? So what are they giving you? They're giving you the rate at which the radius is changing, so dr dt. It's decreasing, so it's a -1/5. They're telling you the height equals 3, right? And they're asking you for dh dt. So what you're going to have to apply here is implicit differentiation. You're taking derivatives with respect to t. So the derivative of r would be 1 dr dt. You follow up every variable with d of that variable over dt. 1/20th is really just a constant, so that can stay out front. When you take the derivative of 3, that goes away. The derivative of h squared would be 2h dh dt. Okay? So take the information you're given and plug in. And remember, you don't have to simplify. So dr dt was -1/5. Okay, h is 3, so 2 times 3. dh dt. And I honestly, this is what I would do. I would leave it as -1/5 all over 1/20 times 6. Units, because it's height, so that would be something like inches per second. And that's your dh dt. Okay, if you want to simplify, then by all means, go right ahead. Don't forget units, but there's really